Welcome to Distributed Generation and Microgrids, unit number 2. This is Dr. Ramu S., course instructor. So, unit number 2 is operational features of grid connected distributed generation systems. In this, we will discuss about grid interconnection issues for grid connected operation of various types of DC systems, and constraints on operational parameters like voltage, frequency, THD, response to grid abnormal operating conditions, islanding issues. And we will discuss about some issues, reliability issues, stability issues, or power quality issues involved in grid connected operation of various DC systems. In unit number 1, we discussed about what is a DC, what is DER, what are the different IEEE standards is required to when you are interconnecting the DCs to the grid, and what is islanding, what is anti-islanding, and what is grid code. All the things, what is basic requirements, or what is the DC, and remaining all aspects we discussed in unit number 1. Now we are moving to the somewhat advanced to the unit number 1. That is, these are the few topics we are covering in unit number 2. The first is grid interconnection. Already we know what is the grid. The grid is interconnection of generation and transmission, generating stations, and transmission and distribution networks. So this is a statement. A wide area synchronous grid is three-phase electric power grid that has a regional scale or greater that operates at a synchronized utility frequency and is electrically tied together during the normal system conditions. So this is a three-phase electrical power grid, have a regional scale and greater than operates at utility frequency, electrically connected, tied or connected during the normal system conditions. Here you can have a look on it. So this is the structure of grid. So this is the coal plant, generating plant. This is one more generating plant. Here we have one more medium sized generating plant, hydro power power electric plant, and here industrial power plant. So these are generating stations or generating system. So from that, either the grid is connecting with the generating, transmission, and distribution, all interconnection of all the things. This we can call high voltage transmission, extra high voltage transmission. So here we can say this is industrial power plant, or this is the load, and this is the distribution grid. In the distribution grid, already in, our DC or DER system, we can connect it at distribution side only. So this comes in a distribution side, the solar farm and wind farm, and the DC which less than 50 megawatt, we can the DC rating is less than 50 megawatt, we can connect it at distribution side, distribution channel. These are all substations, from transmission to the substation to the distribution. These are the different loads. This is the whole structure of particular grid, the grid interconnection of generation, transmission, and distribution. Then here we included with the DC system also. We included the DGs or DER, distributed generations, and we included the DER, the DC plus energy storage system. This is the grid interconnection, how we are interconnecting the three things, the generation, transmission, and distribution and loads. So now we move to what are the impacts of DC integration. So in the last unit we discussed about what is a DC and what is the issues facing when you are connecting to the grid, all the things. Just with a few impacts of the DC integration. First one is a fast response. The load needs a fast response of energy storage system to safeguard from the momentary of voltage fluctuations. Always the user needs the quality of power, the unfluctuated power. So the user side, load side, it's we need the fast response of energy storage system, and we don't need any voltage fluctuations. That means we have to get a pure power. And another one is, another impact is clean power. For the clean power, when you are talking about DER, the DC plus energy storage system. So the excess power are the which is generating from the PV or wind, we are storing in a energy storage system. So the storage power should be converted to the clean power, which you are storing, that we have to convert to the clean power. That is one of another impact. Another one is synchronization. This is the very main point. The smooth control should be there in paralleling and synchronization. So the synchronization is one of the criteria to when you are interconnecting the DCs to the system, or internal DER system. In internal DER system, when you, if you have a two DCs, there also we need a synchronization. And soft transfer, which power you are which power you are generating from the DCs, or which power you are storing in local energy station. We need a soft transfer. Alternative power source should be capable of seamless power transfer. So this is the one more point of soft transfer. So alternative power source should be capable of seamless power system. Alternation power source means what? Here our DC is acting as alternative power source. The best example everywhere in hospitals or any education institute or shopping malls also, or in houses also, we are maintaining diesel generator. That is alternating power source. And isolation. The isolation also another very important point when you are coming with, when you integrating to the DC point to the grid side. So why isolation is required? When the grid is in a fluctuating condition, or any disturbed condition, so at the time the utility grid or our DC must be isolate from the main grid. So isolation, integrating GZ microgrid should be efficient enough to quick isolation from utility in case of any contingencies. So any type of disturbance, or any type of any sort of some the grid is going to the failure condition, it's better to go for a isolated the total it must go to the DC to island condition. So that is one more important point. So few other points are adequate storage. The enough storage is one more impact. So we must have the quality of, already we discussed the PV and wind. It's badly needed a very good storage technology. Same way, those things we are using in as a DC, distributed generation. So the quantity of storage energy should be sufficient to ride through any outage until the primary and secondary power restoration. So what DC available to near to me, or if I want to design one DC in a microgrid, DC or DER, best to take a DER. DER includes of DC and energy storage system. I should take the best quantity of storage technology. So it must store the excess power or generated power from the DCs. It must give the proper power transfer to the when the grid is off condition, or when the power primary and secondary power restoration comes. At the time the user side, you need to get a continuous power supply. For that, when either any fault ride to condition, if any fault is occurred, the utility grid is disconnected to the load, or the load side he may not get a power in that case. So at that case we need a better storage technology. As from the storage technology, then you can give uninterrupted power to the user side. So that point we are discussing here, for right through any outage, any type of outage. So you have to give you have to take this point, adequate storage, like enough storage. Supply to the priority loads. This is a very important point. When the system, when you have when grid failure condition, especially in a grid failure condition or any fault conditions and any severe conditions, the grid is disconnected to the local highlights. First, we have to give the priority to the uh, priority wise loads, like we have to give a high priority to the hospitals. So the hospital must be get a uninterrupted power. So this is microgrid should be capable of supplying clean power to the priority loads of the system. In a system, we have a priority. We have to make it the loads priority. In that priority wise, we supposed to give it. The dispatchability. The microgrid should be capable of supplying power to the varying local loads. Generally, the local loads is varying time to time. So that ability also we have to take a point on this. Then efficiency. Efficiency, microgrid should operate on high efficiency. So why we are discussing microgrid? The DZ is one part of the microgrid. This microgrid we will discuss in unit number 4 and 5. So the DC is a part of the microgrid. So microgrid should operate at a high efficiency. That also one important point. Emission, microgrid should be drastically reduce the DC emissions to minimum. The environmental impacts already we know. Everywhere, if you take any type of new technology or any type of RES also, the main aim is to reduce the emission. So these are the few points of impact of DC integration. The next one is DC integration schemes. We have some different few schemes are there. First one is simple standby generation scheme. Simple standby generation scheme means like you have a locally one DC is there, that we can take it as a simple standby generation scheme. Either our college is there, for college we have a diesel generator is there. College are for houses also now people are going with a diesel generators, that we can take it as a one of the scheme, simple standby generation scheme. So that is a standby. For our college we have standby of diesel generator. If any power cut is there from substation side or grid side, so we are moving to the within a fraction of seconds we are taking power from the diesel generator. Second one is secondary DC system with a power quality support. That means this is another type of scheme. This is another type of scheme, like one secondary DC system, with a power quality support. Power quality support or any capacitor banks, or we can take a shunt or series compensation device, anything that we can take it as secondary DC system with a power quality support. That is one more type of DC scheme. Here the loads will be there, the loads, everything. Third one is primary DC system with a power quality support to the priority loads. Here they properly mention it. We have a different type of loads will be there in this, the DC, either maybe DC with on power quality equipment, power quality support. And for the priority loads, we have a different type of loads. In that we have to give a high priority of loads. That is a one type of scheme. You can say this is the grid side. Okay, these are loads. There is another type of scheme. Third one is soft grid connected DC with power quality support to the priority loads. That means previous one is these two are, it's not connecting to grid. These 3 points are just standby generation scheme is are not connecting grid. Say best example, our diesel generator, we are not pumping our power back to the grid side. The same way secondary DC system and primary DC system with a power qualities. Say primary system we are giving with a priority loads. These 3 things are not connecting to the grid side. The fourth scheme is soft grid connected DC with a power quality support to the priority loads. For this one, we are connecting to the grid. Like suppose this is the DC and power quality support, PQ support, and we have some priority of loads, some different loads. This comes in a third part. This is a third part. If you added the grid, if you add a grid, this is the fourth part. Okay, here we can have a DC, multiple DCs will be there, primary DC and secondary DC. So this is the fourth. Fifth one, a DC with intermittent solar PV with within a power quality environment. So here in DC with DC, and we are taking some PV system also additional to the PV system with additional of PQ. Three things. PV system, and this is PQ support. These are some loads. So this we can say it as DC with intermittent solar power PV. The next one is same as in place of solar PV, wind generation within a power quality environment. Fourth one is ultra high reliability scheme using a dual link DC bus, the DC bus which is connected between our DCs to the grid. So these are different schemes for DC integration.